We're going to be covering analyzing experiment data, focusing particularly on the ANOVA and how to interpret your results. Our presentation topics will first be sources of variance in an experiment. Second, interpreting the ANOVA results. ANOVA stands for Analysis of Variance. And third, why and when to use an ANOVA. Our scenario for introducing us to the ANOVA will be the following. Assume we have two groups, a treatment group and a control group. We used random selection to select the participants and random assignment to each of the groups. Both groups will be drinking water out of the vitamin water bottle container. The treatment group, it actually contains vitamin water. For our control group, it's a placebo. Our hypothesis is that participants who drink the vitamin water over a 2-week period will end up with an average IQ that's different from the control group. There's going to be some non-systematic error variance that will be influencing our results within group variance and sampling error. First, let's focus on the within group variance. When we randomly select and assign the people who will be receiving the placebo, their IQs are not all going to be the same. Some people will be very bright, some people will be much less bright, most people tending towards the middle. That variability among the participants in our control group is referred to as within group variance. We will then calculate the average for our control group. Notice that the average for our control group is not the exact same as the average for the entire population. This difference between the two is referred to as sampling error. For our treatment group, again, it was randomly selected from the population and then they were assigned to the treatment group. Notice that there's variability among the people who are receiving the vitamin water. Again, some who are very bright, most who are average or a little bit above average, it appears, and then a few who are below average. And this difference among the participants in the treatment group is, again, our within group variance. Just random variation due to individual differences. When we calculate the average for our treatment group, notice that it, again, is not the exact same as the population mean, and that the difference between the population mean and our sample mean is referred to as sampling error. It's called sampling error because ideally, if you have a population you randomly select from it, wouldn't it be nice if your sample average was the exact same as the population average? Anytime there is a deviation between the sample average and the population average, that's called sampling error, and almost always that's going to be the case. Because of sampling error, our two groups are not going to start off exactly the same. On this overhead, we can see that there's variation within each of the groups, as well as some variation between the groups, having nothing to do with any treatments or any confounds, but just due to non-systematic error variance. And again, the difference between the two samples is sampling error. So the groups are not going to be starting off exactly the same, nor does this ever tend to occur. Anytime you're going to have random assignment, your two groups will be similar but not exactly the same. Okay, one other point I want to make as we're talking about within group variance and sampling error, I want to let you know that they're related. Consider a scenario where IQ, where almost everyone has a similar IQ. That is, the members are fairly homogeneous. In a case where everyone is fairly similar in their IQ, if we randomly select from that population to form our treatment control group, notice that there's not much variation within each of our two groups, and that there's not much sampling error, fairly similar. If we have a population where there's wider variability in people's IQ and we randomly select, notice that we get much larger within group variance, and our sampling error also tends to increase. And take a look at this case where the population members are heterogeneous. That is, there's a lot of variability in our population for IQ. In this case, lots of variation within each group. and also greater variation between our group means. So there's a relationship that exists between how much variability you see within groups and the amount of variability you see between groups. And this is something that's used by the ANOVA that we'll talk about later. Okay, now we talked about non-systematic effects. Let's talk about systematic effects. There's good systematic effects. That would be experimental variance. That would be, for example, if vitamin water does impact IQ. There's also extraneous variance. That's bad variance. That would be variance result of some confound. For example, if the vitamin water tasted really awful, and so nobody drank it, and yet everyone drank the placebo, they liked it. If we had some large difference between the two groups that was systematic, that's extraneous variance, confound. Okay, so experimental variance, we have our two samples, small little sampling error difference between them. We're going to then go ahead and have our treatment group drink the vitamin water and take a look at that. We saw a big increase in IQ in our treatment group. So before, after. Notice that it's affecting the entire treatment group. That's systematic. That's what systematic means. It affects the entire group. And again, that's good systematic variance. Anytime we have experimental variance, that means our treatment had an impact. Okay, there's also bad systematic effects, and that's our extraneous variance. So again, let's say that the vitamin flavor was off. We went to the store, we bought the vitamin water, and it was a bad batch. It tasted very bad. Meanwhile, our placebo water tasted great, and over 2 weeks, the control group drank their placebo water, enjoyed it. It was just normal water. The treatment group did not drink very much of the vitamin water because it didn't taste good. They became dehydrated, affected their IQ performance. Look at that. They just dropped significantly. So again, that would be something that affect an entire group. See, as it entirely goes down, that's systematic, and that would not be good. So we have two types of systematic effects. Experimental, which is the good stuff, right? You drink the vitamin water, improves IQ, and we have the bad systematic stuff, if there's a confound. The only main point to take about systematic effects is it affects one group primarily, and it affects that group almost all the members.